Hello class, this is lesson 3-1 about representing relations. So to begin, let's talk about a relation. It is simply a pairing of numbers in one set. So you might think of coordinates, but here we're comparing age and length. So it could be the age of a child and maybe the length of their arms or something. And so those beginning values are typically our x values, followed by the y values. Now the x values are also called the input, okay? The y values are called the output. And when I look at the collection of all of those x values, the 2, 4, 5, and 7, that is what we call the domain of this set. It's literally just listing all of those x values. And then the y values, when I put those together, that is called the range, okay? So this is just some terminology as we begin this lesson. So we have input, output, domain, and range. So also you'll notice that this table, I can represent them as points. So 2, 32, or 4, 59, and so on. Like 5, 65, 5, 69, and 7, 71. Okay. I can also represent all of this information or data as a graph. So for my y values, I'm probably going to count by tens. So I'll have 20 and 40 and 60 labeled right there. And then for the x values, I could just count those by ones. So I'll label 2, 4, 6, and so on. And now I can plot all of those points. So I have 2, 32, 4 up 59, 5 up 65, another 5 up 69, and then 7 up 71. So there's one representation of this relation. Another way that you can represent this is what's called a mapping diagram, where we make two columns. One is the input and one is the output. And we're going to write all of our values for the input in number order from least to greatest. And I'm not going to repeat any numbers. So I'm going to list that number 5 just one time. And then you do the same for the output. You're going to list those in order from least to greatest without any repeats. And then I'm going to draw an arrow from 2 to 32 because that was one of my points. And also from 4 to 59, from 5 to 65, and then again from 5 to 69, and then lastly 7 to 71. And that's a mapping diagram. So let's put all this together. Let's use these 5 points to identify the domain and the range, and then we're going to represent this relation as a graph and a mapping diagram. So let's list the domain. Again, it's going to be in number order from least to greatest without any repeats. So I have -1, I have 0, 1, and 2. Those were the x values. And then for the range, I'm going to list all of the y values without any repeats. So the smallest y value is -1, 0, 1, and 2 as well. Okay, now let's go ahead and graph all 5 of these points. So I'm going to go ahead and just draw a very simple graph. Here we go. I'll count by labeling every other one. So I'll label by 2's, and then I can plot those points. So 2, 0, 1 down -1, 2 up 2, 0, 0, and -1 up 1. And there we go. I graphed it. Another way that we're asked to represent this is as a mapping diagram. So remember, we're going to make one column listing our input and one column where we're listing the output. Okay, I already have them written in number order, so -1, 0, 1, and 2, and then again -1, 0, 1, and 2. Based on my points, I can map them. So 2 goes to 0, 1 goes to -1, 2 also goes to 2, 0 goes to 0, and then -1 goes to +1. And I'm done. So now I want you guys to think about graphs that you've seen before and realize that graphs can be used to represent millions of different situations. And so we are going to practice describing graphs every step of the way. So here I have 3 different cars, and I'm going to draw a graph for each car that's representing the speed of that car over time. So here is car number 1. As you can tell, there's 2 different sections, and so I'll draw a little line just to separate those for you to see. But the first section is going up very quickly. See how steep it is? And then the second one is still going up, just not as steep. So in terms of thinking of the speed of this car, I could probably say that the car started to accelerate. That's a good term for speed. And then it sped up even more, right? It doesn't look like it's decreasing in speed because it continues to go up. So here's our next car, and it's going to look wonky, tracking this car's speed over time. Okay, so I see many different sections that I need to describe. So I'm going to go ahead and draw some dotted lines to separate those so that I make sure I describe every single section, especially since sometimes it's going up and sometimes it's going down. So just like the first car, this one is also starting to accelerate from the very beginning and then increase their speed more before slowing down abruptly, because you see how it goes down and it comes all the way to 0, so that means it's slowing down to a standstill. Then the car sped up and continued to increase speed. And that's it. So again, these descriptions are completely up to you, but you need to make sure that you're describing every single section when you're doing this. So for car number 3, I can see that it's starting way up high and then it's coming down, and at the end it comes all the way down to 0. So in terms of speed, it looks like the car quickly decreased in speed. And then for the second part, it looks like then it is slowly coming or came to a halt because eventually it looks like it parked its car. So that's it. For our final example, it says, given the average number of social media posts per day over several years, graph this data by determining the independent and dependent variables, labeling the axes, and choosing a scale and origin to reflect the data. Our independent variable is typically the x, which in this case is the year, and the dependent variable is the average posts per day, because it depends on what year you choose. So now looking at my data, the very first year listed is 2008. So my x-axis I'm going to label as years since 2008. And looking, I go 1 year, and then another year, and then adding 1 more year. So really I can count by ones on the x-axis. Instead of writing 2008, 2009, 2010, I can really equate the number 0 to 2008 and the number 1 to 2009. Now for my y-axis, I can label it as the average posts per day, and this is in the millions. And since I'm starting with 15 million and I'm going all the way to 625 million, I'm thinking I might want to count by 50s. So 50, 100, 150, 200, 250, 300, and so on. So that my scale is going to go all the way from my smallest amount to my largest amount with not a whole lot extra. So I might go all the way up to 650 just so that I can fit in the 625. Okay? And so that's about it for labeling my axes, and I chose a scale that reflected the data. I can now label my graph as social media posts because it's important to have a main title at the top. And then before we graph, let's talk about the origin. So looking at this origin, what does it actually represent? Well, that 0, 0 represents the year 2008, and it also represents 0 posts. Okay, so hopefully you recognize what that really is meaning for this data as well. Okay, so I have all of that. Last thing we need to do is now plot our data on our graph. So I'm going to plot 0 up 15, 1, that's again 2009, up to 20. The next year is up to 35, and then up to 50, up to 100, up to 200, up to 340, just under 350, up to 500, up to 560, and then up to 625. And there you go. So I hope that this lesson made sense. Please let me know if you have any questions when you come into class.